800-ton stones. They're just sitting there in a field in Lebanon. How they got there, that's the quiet riddle. It's not about lost technology, it's not about alien help, it's about a forgotten logic, a practical science. You can see it carved into the earth from Peru all the way to Cambodia. There are 26 principles, universal ones. They let ancient builders move mountains, without any modern machines. By the end, you'll see them. You'll understand why a platform's foundation that mattered more than how tall it was. And the path of a single stone, that path shows you the whole master plan. So what does real ingenuity look like when all you have is time, stone, and human determination? Before you ever see a stone, you have to look down, you study the ground. The way we might look up at the stars, they look down at the earth. That's the first thing, the foundation. A skyscraper today, it's tall because of what's underneath. Deep pilings driven down, anchored to something solid. The ancients knew that, but they worked with what was there. Their question wasn't just where to build, it was what to build on. They looked for the bones of the earth, the bedrock. At Giza, they didn't build on the sand. They scraped down. They scraped all the way down to the limestone to make a level platform. And that platform has held the weight of the pyramids for thousands of years. But if there wasn't solid rock, they made it. They built up hills, compacted earth, gravel, they laid down clay. Layer after layer, tamped it down to distribute the weight to resist sinking. This was engineering from observation. They learned which soils would hold and which would shift. A structure is only as stable as the ground beneath it. That's why so many of these old platforms are still here. They've survived earthquakes, centuries, while later things built on worse ground have crumbled. The logic is simple, it changes everything. It means the most important work happened first, before the monument. In choosing the earth, preparing it. So the story of these stones doesn't start at the quarry. It starts with a footprint. And knowing what's underneath that shape on the ground, it's just a footprint. But the stone that fits it, that comes from the mountain. It's heavy, unwieldy, a raw piece of the earth. So the question is how you make a mountain portable. You don't move the mountain. You take the mountain away from itself. That's the second idea. Mass reduction, working smarter. Think of a sculptor. They begin with a solid block of marble. Their first job isn't to carve the fine details of a face. It's to chip away everything that isn't the statue, to find the general form inside the stone. Ancient engineers used that same logic, but on a scale that's hard to believe. They were sculptors of landscapes. Before a single multi-ton block was ever moved from where it was born, the work started. The stone was dressed down right at the quarry, rough-shaped where it lay. This was a deliberate act of subtraction. By carving off the excess material, by creating preliminary angles and flat surfaces while the stone was still seated in the earth, they were doing a kind of surgical preparation. They were removing dead weight. Imagine pushing a giant, irregular boulder. It catches on every bump, every crevice. Now imagine that boulder, but its sides are smoothed into planes. Its bottom is flattened. It's become a giant block. The friction is less. The path is clearer. The force needed to move it drops. The evidence for this is etched into the earth. In the granite quarries of ancient Egypt, you find the ghosts of obelisks, partially carved monoliths still attached to the bedrock, abandoned halfway. They show the trenches cut around them, the excess stone not yet removed. It's a frozen moment, a snapshot of the reduction phase. Far away in the high Andes you see the same logic on the mountainside. Enormous red granite blocks weren't just cut, they were shaped in place. Their visible faces were finished while they were still part of the quarry wall. This wasn't an artistic choice. It was a critical phase of pre-transport planning. It turned an impossible weight into a manageable, if still colossal, load. Every pound of stone left in the quarry was a pound that didn't have to be lifted, rolled, or dragged for miles. This principle shows a deep understanding of efficiency. The greatest effort went in up front, in the thinking, in the preparation. The hard labor of transport was made easier by the clever labor of reduction. The stone wasn't just extracted. It was engineered for its journey before the journey began. So the monument you finally see resting on its platform, that's not the whole story. It's the refined product, the essence. Everything else, the mountain that once surrounded it, was left behind. A heavy box is on the floor, you push it. It doesn't move, it's stuck. You think it's the weight, then you put some round dowels under. You push again, the box moves. The weight is the same. What changed was the contact. That's the third principle, the geometry of friction. The ancients knew this. They knew moving a stone wasn't about fighting its mass. It was about the surface it touched, so they engineered that contact. They turned a grinding drag into a smooth slide. Look at Stonehenge. The bases of those great stones where they meet the earth aren't jagged. They're dressed flat, carefully worked into a broad, even plane that wasn't for looks. It was physics. A flat bottom spreads the weight over the largest area. It stops point loading. Where one sharp corner digs into the ground like a stake, that creates huge resistance. It could crack the stone. By making that flat interface, they minimized the pressure at any single point. They made the ground a partner. You see the same logic at the andesite blocks. Where one giant block meets another, the surfaces are often curved, concave or convex, a locking joint. But the foundational layer, the stones that touch the earth, show that same flattening. They prepared a highway for weight. So then a flat-bottomed stone is on compacted earth. To move it, you don't just heave. You add a middle layer. You might grease the path, wet clay or animal fat. You might lay down wooden rollers, or as evidence suggests, use a fleet of small, round stones, permanent ball bearings. The flat base glides over these spheres. Friction drops. The hard work of creating that geometry up front made everything after possible. It transformed the problem. Instead of asking how to overcome the weight, they asked how to redesign the journey. So the weight became almost irrelevant. The answer was in the contact, the silent conversation between stone and earth. By mastering that geometry, the impossible became logistics. And that leads to the next step. If you can slide a stone, how do you guide it? How do you make it turn a corner or climb a slope without losing control? The solution wasn't to push harder. It was to think differently about the path. A river doesn't fight the mountain. It finds the gap. It follows the slope. Gravity is its engine. That's the fourth principle. The terrain as a tool. The path of least resistance wasn't a compromise. It was the whole strategy. You don't move a 200-ton stone up a steep hill if you can guide it along a gentle valley. You don't drag it through loose sand if you can wait for the rain and float it on mud. That was hydroengineering, seasonal timing, working with the land, not against it. You can see the logic in the roots. At Angkor Wat, they've wondered how millions of sandstone blocks came from a quarry 35 miles away. The answer might not be a road. It might be a canal. A network of ancient waterways, some still visible, could have turned an impossible overland haul into a waterborne journey. A barge, even with a massive stone, moves with a fraction of the effort. The landscape was the highway. The builders just had to see it. The story of the statues is often about ecological collapse, but look at their journey from the quarry to the coast. The island's topography shows gentle, descending slopes leading away from the volcanic crater. The ground is soft. Some researchers think they used prepared pathways and a lubricant like wet, trampled sweet potato paste. They didn't carry the statues. They walked them upright, rocking them side to side, down a greased road the terrain helped create. In colder climates, the season was the tool, moving megaliths in winter. The ground is frozen solid, hard as pavement. The friction of soil disappears. A sled glides over ice with startling ease. Evidence from northern sites suggests this wasn't just possible but probable. The monumental effort was scheduled, calendar-based. They waited for the land to become cooperative. This principle flips the narrative. It means these builders weren't just masters of stone. They were masters of reading the landscape. They understood hydrology, soil mechanics, seasonal change. A hill wasn't a barrier. It was a potential ramp. A muddy flat wasn't a trap. It was a natural lubricant. A frozen tundra wasn't a wasteland. It was a ready-made transport route. The genius was in the observation, seeing what the earth offered each season and planning the impossible task around that gift. So the route of a monolith was never a straight line. It was a negotiation, a dialogue between human intention and the living, changing body of the land. And if the land itself could be a tool, what about the stone? Could its own nature be used to shape it? The stone reaches the site, and the work changes. Now you have to lift it, not just once, but again and again. Higher each time. This is where the thinking becomes architectural. The fifth principle is the incremental lift. You don't build the mountain all at once. You build it one handful of earth at a time. The secret was a cycle, a patient rhythm of ramp and fill. Picture the pyramid not as a triangle but as a process, a growing earthen hill with a stone skin. Builders would make a temporary ramp of packed earth and rubble against what they'd built. Up this slope, teams hauled the next layer of facing stones. They set them with precision. But then they wouldn't take the ramp down. They did something smarter. They filled the entire space behind that new wall with more rubble and earth. They packed it down. That did two things. It stabilized the new outer wall, locking it in place from behind, and it raised the whole working platform. The builders were now standing on a new, higher level of their own creation. From that new ground, they'd build the next section of ramp, haul the next stones, and fill again. The structure grew from the inside out, from the ground up. A slow, deliberate spiral. That growing mound of interior fill wasn't waste. It was the scaffolding. It was the support. You can see this cyclical accretion in the bones of ziggurats in Mesopotamia. Those step temples are a series of filled boxes, each one smaller than the last. The fill inside each tier provides the mass to support the next. At Giza, the evidence is in the layers. The Great Pyramid isn't a solid block. Its core is a jumble of local limestone packed with clay mortar. The fine outer casing stones form the precise skin. The ramp wasn't a single roadway to the top. It was a dynamic system that wrapped the growing structure, constantly being extended and recycled. This method turns an impossible vertical lift into a series of manageable horizontal pulls. The grade of the ramp is everything. Too steep and you lose the advantage. Too shallow and the ramp becomes impossibly long. They found the balance. A slope a team could walk up, dragging a sledge. This incremental logic is profound in its patience. It shows a society thinking in generations, not seasons. The monument rises not from a single burst, but from the relentless seasonal return of labor, a harvest of stone. Each year after the floods receded in Egypt, the workforce would return. They'd extend the ramp another level, set another course, fill another chamber. The project was a rhythm embedded in the calendar and the land. So when you look at these colossal platforms, you're not just looking at a finished product. You're looking at a captured process, a snapshot of a cycle repeated thousands of times. The mountain was built by convincing gravity to help, one small lift at a time. But once you have this stable, rising platform, a new question emerges. How do you ensure it lasts? How do you lock these stones together so they become a single, unshakable mass? The answer is in the joints. The sound of 1,000 people pulling a rope isn't one sound. It's a rhythm, a deep pulse, coordinated. That's the sixth principle, the leverage of the crowd. It turns human strength into something else, into a system. The old idea of mindless slave labor, the evidence doesn't support that. Points to organized work, skilled labor, it's social engineering. The real machine wasn't the crane, it was the crew. Their power came from synchronization, perfect timing. One person pulling a rope does nothing. 100 people pulling at random is just chaos. But 100 people pulling on the beat of a drum in a steady, rocking rhythm that creates a wave of force, that can walk a stone up a ramp. They used the tools of coordination. Thick ropes, woven fiber, massive wooden sledges greased. And the simplest machine, the lever. A team would get a strong timber under a stone's edge. On command, they'd push down together. The stone would lift just an inch. They'd shove a wooden block underneath, then reset, lift again, another block. This inchworm process, repeated by teams in shifts, could raise a multi-ton block onto a platform in a day. It was relentless, patient, brilliant in its simplicity. For moving things horizontally, the capstan was key, a large, vertical wooden drum. Teams of walkers would push long spokes radiating from it, like a giant wheel on its side. A rope wound around the drum would tighten, pulling a sledge forward with immense mechanical advantage. The key again was the rhythm of the walk, a steady marching pace, not a sprint, a controlled collective effort. You can see this coordination in the artifacts. In ancient Egypt, tomb paintings show rows of laborers hauling a statue on a sledge. A figure stands on the sledge itself, pouring a liquid ahead of it, probably a lubricant. Another figure, often seen as a foreman or a timekeeper, claps his hands, setting the beat. This wasn't about cruelty, it was about physics. A synchronized pull is exponentially more powerful than a disorganized one. We see this pattern everywhere. In the jungles of Cambodia, moving sandstone blocks for Angkor. On the Pacific Islands, raising the great stone heads. In the highlands of Peru, fitting the polygonal walls of different cultures, the same fundamental understanding. The human body is a remarkable engine, but its true potential is unlocked in unison. The chant, the drum, the clapped hands, that was the operating system. It turned a crowd into a single living machine, capable of feats that still stagger us. So the monument isn't just a testament to stone. It's a fossilized echo of that rhythm, of 1,000 voices finding one beat. And once that stone is raised and set, how do you ensure it stays? How do you make separate pieces act as one? The answer is in the fit. Two stones meet. No glue, no mortar, just the shape of one pressing into the other. That's the seventh principle, the keystone of dry masonry. Interlocking without a binder, a puzzle made of giants. You see it at Above or the Lion Gate at Mycenae. Massive, irregular stones. Their edges aren't straight. They're complex curves, angled, jigsaw cuts. Each block was shaped over countless hours to fit one specific neighbor, and only in one orientation. Lithic puzzle making. The logic is profound. A wall with rigid mortar is strong but brittle. When the ground shakes, that wall wants to move as one stiff unit. The mortar cracks, the structure fails. But an interlocking dry stone wall is different. It's a flexible mass. Seismic energy travels through it and the stones can shift. They can rock and settle. Those complex three-dimensional interfaces allow for tiny movements. The energy dissipates as friction between the stones, not concentrated into a single catastrophic crack. The wall breathes, it adjusts, and when the shaking stops, the stones settle back into their locked embrace. This is a deep, intuitive understanding of structural dynamics. The builders weren't just stacking weight, they were creating a living system. They understood stability isn't about being rigid, it's about being resilient. About distributing forces, the proof is in the endurance. These walls have stood for in the most seismically active regions on Earth. They've survived what modern buildings just miles away have not. The process to create it was an act of supreme patience. It likely involved trial fitting. A stone would be roughly shaped, brought near its intended place. The masons would examine the gap, mark the high points on the new stone, take it away, carve those points down, bring it back, check again. This cycle repeated until the contact was near perfect over the entire interface. The final act was often to create a slight convexity on one face, fitting into a concavity on the other, a locking joint. This wasn't about vanity. It was about creating a wall that was more than the sum of its parts, a wall that became a single geological entity. The genius is in the negative space, in the invisible, perfect fit. It turns brute mass into intelligent architecture. So the platform's strength didn't come from a chemical adhesive. It came from geometry, from a shape conversation between stones, whispered so precisely not even a blade of grass could pass between them. And if stones can be made to hold each other, what about the entire structure? How do you ensure the whole platform is perfectly aligned, not just with itself, but with the world around it? The quarry isn't just a hole, it's the first workshop. The principle is seeing source to site as one continuous system, a production line carved right into the land. There's the unfinished obelisk at Aswan. It's still there, lying in the granite attached at the base. The whole process is frozen. The workers didn't just start chipping, they read the stone first. They followed the natural fissures, the lines of weakness in the granite. They drove wooden wedges into those cracks, then soaked them. The wood swelled. And with that patient force, it split the stone along a clean plane, extraction by persuasion. And once the stone was free, the work didn't stop. The shaping began right there while it was still in its cradle of bedrock. Masons would dress the sides, create those flat planes, those preliminary angles. They were turning raw geology into a manageable component before it ever moved. That was critical. Every ounce of stone removed at the quarry was an ounce you didn't have to drag for miles. So the quarry was the first construction site. Its location was never an accident. Take the andesite blocks for Puma high in the Altiplano. The quarries weren't just nearby, they were positioned relative to the destination. The route from quarry to temple is a gentle descending slope. They chose a source that let gravity assist the whole journey. They weren't just picking a rock, they were engineering the supply chain from the first cut. In Egypt, the Aswan quarries sit right on the Nile. A block once shaped could be loaded straight onto a barge. The river became the conveyor belt. The landscape was the factory floor. This thinking minimized handling. It eliminated intermediate stockyards. A stone was born, shaped, and sent on its way in one sequence. The logic is profound efficiency. It treats the whole operation, extraction, reduction, transport, as a single problem. The monument didn't begin at the building site. It began deep in the mountain, with a careful tap of a wedge on a slope that led all the way home. So the stone arrived not as a raw burden but as a prepared piece. But once you have a system this efficient, how do you feed it? How do you sustain the thousands of hands? Year after year, the stone has a secret. It's not just a block, it's a choice. The ninth principle asks why this stone and not a different one. Why granite in this spot, limestone over there, sandstone somewhere else? The answer sits where two maps cross. One map is of the earth. It shows hardness, fracture, lines, weight. The other map is of the mind. It shows meaning, memory, what's sacred. The builders read both. Take the red granite from Aswan. It's brutally hard, a nightmare to quarry, to shape. Its compressive strength is phenomenal. It can hold immense weight without crushing. That's the practical geology. But why go through that nightmare? Because its durability mirrored an idea: permanence, eternity. In the Egyptian view, granite was the flesh of the gods, the bone of the earth. To use it for a king's sarcophagus or the point of an obelisk, that wasn't just a technical decision. It was a theological one. The material guaranteed the message. It said this will last as long as the world. Basalt tells a similar story. You find it at places like the Giant's Causeway. It was used for ancient statues. It forms from lava cooling fast, becoming dense, fine-grained. It resists weathering incredibly well. That's the engineering logic, but its volcanic origin tied it to raw creation, to the underworld, to a transformative power. Choosing basalt meant weaving the violence and fertility of the earth right into the foundation. This duality shaped everything. Starting at the quarry, a source wasn't picked just because it was nearby. It was picked because its stone meant something. The journey from that sacred quarry to the temple was a ritual, a procession. The stone was being brought home, from a place of power to a place of worship. The platform became a point of convergence, where the enduring strength of the earth met the enduring will of a culture. You see it with the green stone prized for ceremonial axes, or the blue stones of Stonehenge, hauled over 200 miles from Wales. Their unique spotted look, their supposed healing properties that likely mattered as much as how easy they were to work. The immense effort to move them changed them. From ordinary rock into sacred relics, their presence in the circle was the point. The platform's substance was its first declaration, its most profound one, so to see only the engineering is to miss half the blueprint. The stone was chosen for its soul as much as its strength. It had to perform a physical function, to bear weight, to resist time. And it had to perform a cultural function, to embody a belief, to connect the human to the eternal. This intersection turns a technical analysis into a deeper story. The monument doesn't just stand on the earth, it's in conversation with it, using a language of geology and meaning the builders understood perfectly. And if the material itself is part of the message, then every cut, every angle, every joint has to speak too. How do you make stone communicate? Stone is one part of it. The other part is water. Water moves, it finds its way in, it wears things down over time. It's the one thing that can take a mountain apart slowly. And the people who built these places understood that. They weren't just trying to block water out, they were trying to steer it, to work with it. That's the 10th idea. The platform as a machine for handling water. If you look past the outer stone of those big pyramids underneath there's usually other materials. Layers of gravel, sand, clay. That's not just packing material, it's a filter, a drainage system, but huge. Rain would fall on the stepped sides, run down and soak into those layers. It would get directed away from the packed earth core that held the pyramid's form. Without that, the whole thing would get wet inside. It would soften and then it would collapse, like a sugar cube dissolving. Then there's Angkor Wat. The temple isn't just sitting next to a moat, it's the focal point of a whole engineered water system. That moat is a giant storage basin. It keeps the water level under the temple's foundation steady. It stops the sandy ground from moving too much when the seasons change from very dry to very wet. But it goes beyond the moat. The whole site is built with slight slopes, underground pipes, overflow routes. When the heavy monsoon rains came, this network would catch the water. It would guide it, let it out slowly. That kept the base of those tall towers from being washed away. It made the temple like a ship, balanced on this controlled environment of soil and water. This thinking finds its highest expression somewhere like Tikal. The Maya built their cities on limestone high ground. They made huge reservoirs sealed with plaster to collect rainwater because there weren't any rivers. They placed their pyramids and platforms within this water capture landscape. The water was for more than just survival. It was for rituals, for cleansing. From this angle, the platform becomes an altar in a ceremony about keeping nature in balance. It handles the spiritual and the functional together. The water has to move for there to be life, but it also has to be managed to protect what was built. It shows a complete kind of intelligence. The builders didn't see their structure as a separate thing. They saw it as a new part of an old terrain. They had to anticipate how water would act for hundreds of years, where it would collect, where it would run off, how the foundation would relate to the groundwater through cycles of drought and flood. Their engineering was a conversation with the climate. So the greatest platforms were never completely still. They were active with controlled movement. The stone gave them their shape, but the hidden waterworks gave them their permanence. It was a collaboration between what is solid and what flows. And if they could fit water and stone together that precisely, it makes you wonder about the last element, the most difficult one. What about the gaps in the stone? And the light that goes into them? Sunlight doesn't simply land on these places. It arrives at a precise angle on a specific day, coming through a particular opening. That's the 11th principle, the need for astronomical alignment. The platform as a kind of clock, a compass built from an understanding of the stars. And this is more than just symbolism. It's the deepest form of long-term planning. To line up a structure with a solstice sunrise or with the rising of a certain star, you need more than a general sense of it. You need generations of patient watching. You need a calendar that can predict the sky cycles. And then you need the skill to take that celestial map and translate it into a foundation on the ground with an accuracy that lasts for thousands of years. Think about the darkness before dawn. On the winter solstice, the sun comes up over the mountains, and at the exact moment it appears, a single beam of light passes through a window in the temple of the sun. It hits a ceremonial stone inside perfectly. This wasn't an accident. It was the result of centuries of observation by the Inca and by people before them. The whole site, its terraces and temples, they're all oriented to this solar axis, this mountain axis. The platform had to be perfectly level, the walls perfectly placed, to catch that one beam on that one day every year. The engineering existed to serve the astronomy. The structure was a machine for marking time. And this logic appears everywhere. The sides of the Great Pyramid are aligned to the cardinal directions with an error of just a tiny fraction of a degree. That precision suggests a surveying method using the stars, maybe by following the circular path of a single star around the pole. The builders didn't just want a square base. They wanted a base that was squared with the cosmos itself. At Stonehenge, the heel stone marks the summer solstice sunrise from the circle's center. But the whole arrangement of stones, the blue stones they also track lunar cycles. They track eclipses over a much longer period, an 18-year cycle. The platform, the circle, it's a permanent record of celestial patterns observed over many lifetimes. The engineering challenge in this is profound. It means the very first act, the foundational survey of the site, had to be astronomically correct from the start. A mistake of an inch in that initial alignment would become an error of feet by the time the structure was finished. They used simple, brilliant tools. A gnomon, a vertical stick, casting a shadow to track the sun's path. The merkhit, an Egyptian sighting tool for aligning to stars. With patience, these simple instruments could achieve a staggering accuracy. This changes what the platform is. It's not just a stage for a temple. It is the temple's first and most important instrument. Its alignment embeds an understanding of time, of seasons, of cosmic order directly into the earth. The platform becomes a kind of bridge. Its stones are anchored in the ground, but its design is fixed on the turning sky. It shows a society thinking in cycles much larger than a single human life. They were building calendars in stone, meant to outlast empires, to keep marking the seasons long after the builders' names were forgotten. The monument was their way of speaking to the future, saying we were here and we understood the rhythm of the world. So the true foundation was knowledge, a deep generational memory of the stars translated into rock and angle. And if the platform can be aligned to the heavens, it makes you wonder about the world beneath our feet. How do you make sure it speaks to the living landscape with that same power the platform speaks a language you can't see? You have to listen for it. In deep chambers underground or in halls with no windows, the air can hum. That's the 12th principle, the acoustic dimension. Where engineering meets the invisible world of sound. Take the hypogeum of on Malta, a labyrinth carved from solid limestone over 5,000 years ago. Something strange happens there with the human voice. In one specific oval chamber, the oracle room, a deep male voice at a certain pitch, it doesn't just echo, it resonates. The sound vibrates through the stone, through your bones. It creates a feeling that seems to come from everywhere at once. The chamber itself becomes an instrument. Then in the Peruvian Andes, a network of underground galleries built with narrow, twisting ducts. When a conch shell trumpet is blown at the entrance, the sound doesn't travel straight. It bends. It gets channeled through these stone tubes. It emerges in other parts of the temple as a distorted, otherworldly echo. It sounds like it's coming from the walls, from the gods themselves. This was likely no accident. It was a forgotten branch of architectural science. The logic wasn't just about holding up a roof. It was about shaping the experience inside it. By carving chambers with specific proportions, with parabolic walls or precise volumes, the builders could tune a room like a drum. They could make it amplify certain frequencies and dampen others. A chant, a drumbeat, a blast from a horn, it would be transformed. In a ritual context, this acoustic engineering had a purpose. It could induce awe, disorientation. transcendence. Very air would vibrate with power, making the spiritual experience visceral. Undeniable, it was a technology of atmosphere, the ultimate surround sound system carved from living rock. They understood sound as a physical force. It bounces, it gathers, it can be focused. By designing the hard, reflective surfaces of their sacred spaces with intention, they turned architecture into a conductor for ceremony. The platform or the temple wasn't a silent monument. It was an active participant. Its voice activated by the breath and song of the people within it. This reveals a layer of sophistication we often overlook. Their mastery extended into the realm of senses we can't touch. They designed for the ear and the feeling in the chest as carefully as for the eye. It suggests their world was alive with frequencies we've since learned to ignore, and their greatest buildings were instruments to make those frequencies sing. So the legacy of stone is not a silent one. If you listen closely in the right place, you might still hear the echo of their intention. A whisper of vibration trapped in the geometry. For a single stone is a marvel, but 1,000 stones all fitting together, that's a system. The 13th principle is modular design. It's the logic of the repeatable unit. A modern factory makes identical parts to build 1,000,000 cars. Ancient builders used a similar idea. They managed impossible scale. They didn't see a wall as one endless problem. They saw it as a series of identical solvable tasks. Look at the Great Wall of China, the later Ming Dynasty sections. The watchtowers are spaced at regular intervals. The bricks are a standard size that allowed for division of labor. One team could be making bricks in a kiln using a single mold. Another team could be laying the foundation. Another could be building just the towers. The process became predictable. It became faster. Quality was easier to control. You were checking against a known standard. This same modular thinking is in the stones of megalithic platforms, even where they look irregular. At a site like the wall looks like a chaotic jumble of giant polygonal blocks, but you look closer, there's a hierarchy. A foundation of the largest, most irregular stones, then a middle course of slightly smaller, more manageable blocks, then a top course of smaller stones, often more uniform. This is a system. The massive foundational stones provide stability. They lock the wall into the earth. The middle-sized blocks fill the bulk of the structure. The smaller capstones finish it. Each size class was a module for a different phase of the work. The quarry teams knew what sizes to produce. The transport crews knew what weights to expect. The masons had a mental catalog of fits, how a large module typically joined with a medium one. That turned artistic complexity into an engineering workflow. Even the famous multi-ton blocks at Baalbek show this logic. The stones, those 3 colossal blocks in the podium, are nearly identical in size. They are a module, repeated 3 times. Their sheer scale makes them seem unique, but their uniformity reveals the plan. They were the standard unit for that foundational tier. This modular approach had a social impact. It enabled large-scale, coordinated labor without constant, top-down micromanagement. A crew could be trained on one specific task, shaping the standard middle-sized block, or laying the standard foundation course, and then repeat that skill efficiently. The project could scale up by adding more crews doing the same, proven tasks. It turned a singular monument into a series of mass-produced components. The genius is in the balance. The system provided order and efficiency, but within that framework the masons still had flexibility. They could make each unique fit perfect. The module gave them the starting point, the known quantity. Their skill did the rest. So what looks like a wild, organic growth of stone is often a deeply organized operation, a symphony composed of a few powerful, repeating notes. And if the structure itself is built from modules, what about the space it creates? How does the empty area, the courtyard or the plaza, become part of the design? The greatest marvels are the ones you never see. They leave no trace. The 14th principle is the invisible infrastructure, the logic of temporary works, everything that was built to be taken apart. The colossal earth ramps that wrapped the pyramid as it rose, the intricate wooden cranes, the lifting frames, miles of thick hemp rope. Temporary clay slipways, greased with water or fat. These were the true engines. They bore the impossible loads just once and then they were gone. Their design is a lost chapter of applied physics, a sophisticated understanding of forces, static and dynamic, all executed with materials that nature reclaims. Think of the ramp. Its angle wasn't guesswork. Too steep and the teams couldn't pull the sledge. Too shallow and the ramp's length became absurd. It would require more material than the pyramid itself. They found the sweet spot, likely through generations of trial, and the ramp's composition was engineered. Layers of rubble, clay, limestone chips, compacted into a temporary roadway strong enough to support sledge paths, for stones weighing multiple tons. This was a disposable mountain, built to create a permanent one. Or the ropes, the strength of a woven fiber cable, its elasticity, its resistance to sudden shock loads, that was critical knowledge. A snapped rope under that much tension wasn't just a delay, it was a catastrophic danger. They understood load distribution, how to rig multiple ropes to share the strain, how to use wooden rollers and levers as force multipliers. The lifting frames, the A-frames of timber, they acted as primitive cranes, designed for a single Herculean task: to inch a block upward, hold it while a wooden crib was built underneath, and then be reset. Their design balanced strength against the sheer weight they had to bear, for a short, critical moment. All of it, the ramps, the ropes, the frames, was engineered for a temporary purpose with permanent consequences. Infrastructure in the truest sense. The support system that vanishes into the ground, leaving only the monument above to tell the tale. It shows a profound humility in their approach. They invested immense labor into tools they knew would be discarded. The glory was for the stone that would last forever. The clever, practical work was in the wood and earth that made it possible, and then returned to the soil. So when we stare at these silent platforms, we're only seeing half the achievement. The other half was a bustling, temporary city of ingenuity that evaporated once its job was done. It asks us to look at the empty space around the stones and see in our mind's eye the vanished machinery of creation. A perfect monument tells you what succeeded. An unfinished one tells you how they thought. That's the 15th principle, the failure as a lesson. A crack in the stone, a toppled giant, these aren't accidents. They're frozen moments, a record of a problem encountered in real time. They offer a forensic look at the limits of their methods, and that view is priceless. So you go to the granite quarries of Aswan. There's the unfinished obelisk, still attached to the bedrock, a colossal ghost of a project, and it cracked. A deep, fatal fissure appeared along its length during the quarrying. For us, that crack is a textbook. It shows where the stresses became too great. It reveals the precise moment the stone's internal structure failed under their techniques. They were likely using a method of heating and cooling, or driving in wooden wedges they'd soak with water to expand. The crack tells us they pushed that method to its absolute boundary, and the stone said no, so they walked away. That abandonment is as instructive as the success. It shows they knew when to stop. They understood a flawed foundation stone, even one of that immense size and value, could not be used. The integrity of the final product mattered more than the sunk cost of labor. Then you travel to the slopes of On. The landscape is littered with in every stage of creation. Some are barely outlined in the rock. Others are almost free but still attached at the back. And along the ancient roads leading away from the quarry you find the fallen, the giants that never made it to their platforms. These toppled statues are like paused experiments. Their positions tell a story. Did the transport crew lose control on a slope? Did the rocking walking technique fail at a certain angle? Did the statue's center of gravity shift in a way they couldn't compensate for? Each fallen marks a specific point of failure in the logistics chain. It's a data point. For the next team, moving the next statue, that failure became a lesson. Perhaps they adjusted the route, or changed the lashing points, or waited for drier ground. This forensic approach changes our perspective. It dismantles the myth of seamless, effortless genius. It shows a world of trial and error, of brilliant solutions born from repeated hard-won experience. They didn't have computer models. They had stone and muscle and observation. When something broke, they examined why. They learned the tensile strength of their granite. They learned the tipping point of a multi-ton statue on a greased path. Each failure refined the next attempt. So these silent failures are among the most eloquent teachers. They don't show us a perfect, finished idea. They show us the thinking in progress, the struggle, the point where ambition met the unyielding laws of physics. And in that meeting, we see their true ingenuity, not in never failing, but in learning, adapting, and carving their next success from the bones of the last attempt. This process of adaptation leads to a final question. If they could learn so much from a single crack or a fallen statue, what was the ultimate purpose of all this accumulated knowledge? What were these platforms built to do? In the long arc of time, a technique shows up in Egypt. Then you see it in Peru, and something like it appears in Cambodia. That's the 16th principle, the puzzle of cultural transmission. Did the idea travel, or did it just come up again? The answer is in the problem itself. When cultures are separated by oceans and time, and they face the same basic challenge, how to move a mountain with human hands, they often find similar answers. It's convergent technological evolution. The lever, the ramp, the roller. These aren't secrets passed down from one teacher. They're conclusions drawn from the same physical laws. Gravity works the same in the Andes as it does along the Nile. Friction is the same in the Cambodian jungle and on the coast of Malta. When you push against something immovable, a 100-ton stone, the ways to move it are actually pretty limited. You can lift it, you can slide it, or you can roll it. The ingenuity is in turning those basic actions into a system. So the pyramid shape isn't a blueprint. It's the most stable form for stacking immense weight. Cultures from to Mesopotamia arrived at it independently because the math of stability led them there. The inclined plane, the ramp, is the simplest machine for turning horizontal pull into vertical lift. It would be more surprising if builders, trying to raise stones high, didn't invent it. The use of levers and rollers comes from a universal observation. A round object moves easier than a square one, and a pivot point can multiply force. These aren't mysteries waiting for a guru. They're truths written into the world, discovered again by anyone who looks closely at a log, a rock, a stubborn problem. This doesn't make the achievement smaller, it makes it larger. It means human ingenuity, when faced with a monumental task, follows a kind of universal logic. The shared toolkit of ancient mega-engineering, the prepared foundation, the shaped stone, the coordinated pull, the interlocking joint, it comes not from one lost civilization, but from the repeated, brilliant application of human observation to universal constraints. The platforms of Angkor Wat, the walls of, the columns of Baalbek, they aren't siblings from a common parent. They're distant cousins, born from the same family of needs and the same inheritance of human cleverness. Their similarity doesn't testify to a shared history. It testifies to a shared humanity, solving the same equations in stone. A monument isn't just stone, it's bread, it's grain. Thousands of full bellies day after day for generations. That's the 17th principle, energy economics, the caloric fuel. To move a mountain, you first have to feed the people moving it. That's the forgotten logic, agricultural surplus, social surplus. Building a platform was an exercise in farming. In storage and distribution, as much as it was in physics, it was a society-wide battery, charging itself with sunlight captured in crops, discharging that energy into reshaping the earth. So the math, a workforce of 20,000 people, laboring for 20 years, that's a staggering number of meals, millions of pounds of grain, thousands of cattle, an endless supply of water. This wasn't a summer project, it was a permanent parallel economy, running alongside the daily life of a civilization. The true foundation of the Great Pyramid wasn't just the Giza Plateau, it was the fertile fields of the Nile Delta miles away. The annual flood of the Nile provided the predictable surplus. It produced more barley and emmer wheat than the local population needed just to survive. That extra food was the fuel, collected, stored in vast granaries, redistributed as wages, bread, beer, and fish. This system reveals an astonishing level of organization, socioeconomic organization. It required planners, scribes, overseers. It required a transportation network to move food from farms to the remote desert site. It required potters to make millions of vessels for water and grain. It required bakers and brewers working at an industrial scale. The Monument project created jobs far beyond the quarry and the ramp. It was an economic engine. It structured an entire society for decades. We see this pattern mirrored across the world. In the Andes, the Inca Empire's monumental structures were powered by agricultural surplus, terraced mountainsides, state-controlled storehouses called in. The maize surplus from farming fueled the construction of vast ceremonial centers. The platform rose because the harvest was plentiful and meticulously managed. This changes the scale of the achievement. It wasn't just that they could move a 200-ton stone. It was that they could convince 20,000 people to show up day after day. and have the confidence to feed them all. That required stability, foresight, a shared belief in the project's purpose. The workers weren't slaves in chains. They were likely seasonal laborers, farmers who worked the land when the Nile was high and came to the king's project when the fields were fallow. They were paid, housed, and fed. The project was a societal ritual, a way to convert agricultural abundance into eternal cultural capital. So the silent stone platform speaks of a vibrant, humming, organized world, grain sacks and water jars, ledgers and ration quotas. The true monument is the system that built it, a civilization so adept at harnessing the energy of its people and its land that it could spend generations building a message for the future. And if a society could organize itself to that degree, what was the ultimate return on that immense investment? What did they believe they were purchasing with all that bread and stone? The stone scale is the message. It reaches your body before your mind can catch up. That's the 18th principle where engineering meets psychology, all as a design goal. The platform wasn't just meant to be seen, it was meant to be felt, to make you standing at the base feel a specific thing, your own smallness. In the face of something immense, something permanent, that emotional impact wasn't a byproduct, it was a requirement. As calculated as the angle of a ramp or the fit of a joint. Take the experience. You approach a site like the Temple of Jupiter at Baalbek. The podium stones are over 60 feet long. Just to reach the floor level of the vanished temple, you climb a modern staircase. It feels like scaling a cliff. Your neck cranes back. The mass of stone above you blots out the sky. That physical sensation of being dwarfed, that was the whole point. It was a form of communication without words, written in granite and limestone. It said the power that built this is beyond your understanding. It's as fixed as the earth, as eternal. Whether that power was a god, a king, a divine ruler, the architecture made it tangible. You didn't just hear about their authority, you stood in its shadow. This logic of psychological scale shows up everywhere. The steep steps of a pyramid like El-At, they aren't just a staircase. They're a barrier. The climb is arduous, deliberate. The summit is reserved. By making the ascent hard, by making it visually dominant, the design creates a separation. Between the sacred space above and the common ground below, it reinforces a hierarchy, a social one, a spiritual one. Through pure geometry, you look up and you understand your place. Even in structures meant for gathering, like the great platform of Stonehenge, the scale manipulates perception. The outer circle of sarsen stones capped by lintels creates a ringed space, a contained space, but from the center looking out, the horizon is framed by these gigantic pillars, controlled. The world outside the circle feels distant, managed. The architecture defines more than a physical space. It defines a psychological one, a separate realm where the everyday rules are suspended. This was engineering for the human spirit. The builders understood to shape belief, to cement social order, you first shape experience. They used the raw language of mass and height, of inaccessible peaks and looming walls, to generate a universal response. Awe, humility, submission. The platform was the ultimate tool of persuasion, silent, utterly convincing. Its emotional payload was delivered by the sheer fact of its existence. So when you see a photograph of one of these places, and you feel that quiet pull, that sense of profound scale, you're feeling exactly what you were meant to feel. The blueprint included your wonder. The ground moves, it shakes, it rolls, and in the most active places the monuments are still there. That's the 19th principle, seismic adaptation. Building to dance with the earth, not fight it. It's a dynamic logic. It anticipated the violence of the ground and turned it into a conversation. In the Andes, where the plates grind together, you see it everywhere. Look at the doorway. They aren't rectangles. They're trapezoids, wider at the base, narrower at the top. That's not an artistic choice, it's physics in stone. When an earthquake's lateral forces hit a rectangular opening, the stress concentrates at the top corners. Those right angles are weak, they crack. But a trapezoid with its sloping sides redirects those forces downward, into the massive walls. It's a funnel for energy guiding it into the ground. And the walls themselves often slope inward, just slightly. That gives the whole structure a lower center of gravity, like a pyramid. It makes the building want to settle into itself during a shake, not topple. Then there's the stonework, the interlocking polygonal puzzle. That's a wall of perfectly fitted, irregular blocks isn't rigid, it's a flexible matrix. When seismic waves pass through, the stones can shift. They can rock and settle. They grind against each other, and that friction turns the quake's energy into heat and sound. The wall breathes, it adjusts. and when the shaking stops, gravity pulls each stone back into place. The wall is often stronger for it. It's a profound understanding. Modern engineers have terms: base isolation, energy dissipation, letting a building move independently of the ground or absorbing the forces. The ancients were practicing this ago with stone and geometry. At places like you see it in every joint, the stones are beveled, their edges are rounded. That prevents chipping during those tiny movements. It's a detail that shows they weren't building for a static world. They were building for a living, moving planet. Their platforms were shock absorbers. The foundation, often a deep bed of gravel or rounded stones, could act as a rolling layer, letting the structure above slide slightly. This is engineering that listens. It doesn't impose a foreign rigidity. It creates a resilient system that speaks the same language as the earthquakes. So these platforms that have survived for centuries in the most unstable zones aren't just lucky. They're intelligent. They are dialogues in stone, with answers prepared for the Earth's most violent questions. The last stone is set, but the work isn't over. The 20th principle asks what happened next after that final block was fitted. It's the mystery of the surface treatment, the lost finishing techniques. We look at these colossal stone platforms now and we see raw, weathered rock. But that's not how they were meant to be seen. That's the skeleton after the skin has vanished. The true final layer was a sophisticated surface, a protective skin, a beautiful skin. It completed the visual design and shielded the core from the elements. This was engineering at the molecular level, a marriage of chemistry and artistry. Think of the Great Pyramid at Giza. For thousands of years, it wasn't a stepped mountain of rough blocks. It was a smooth, gleaming prism. Its entire exterior was sheathed in polished limestone. Those casing stones were cut with such precision that the joints between them were nearly invisible. From a distance under the desert sun, the pyramid would have appeared as a single, blindingly white geometric form. That casing wasn't just for show. It acted as a continuous, seamless barrier. It shed wind-blown sand and rain. It protected the softer, rougher core masonry inside. The loss of that skin, a way for other buildings over centuries, changed our perception of the structure. It went from a refined, finished monument to what looks like a rough stone hill. We're seeing the armature, not the sculpture. This logic of surface engineering appears across the ancient world. The Great Pyramids were never bare stone. They were coated in thick layers of stucco, a lime plaster made by burning limestone, slaking it with water, mixing it with sand. This created a hard, white, paintable surface. Teams of artisans would cover this canvas with vibrant murals, intricate designs, symbolic colors. The pyramid for example, was a brilliant red, decorated with patterns and imagery. This stucco skin was more than decoration. It was a vital weatherproofing system. The lime plaster is slightly flexible as it cures, and it forms a breathable yet water-resistant seal. It prevented rainwater from seeping into the rubble and earth core, which would have caused erosion and collapse over time. The chemistry involved was advanced. Creating high-quality lime plaster requires controlling temperatures in kilns, understanding the slaking process to achieve the right consistency. They often added organic materials like plant gums or cactus juice to improve workability and durability. This was material science, applied on a monumental scale. The loss of these finishes creates an illusion. It makes the underlying construction seem cruder, more primitive than it originally was. When we see the rough Cyclopean blocks of a Mycenaean fortress or the stacked core of a Mesopotamian ziggurat, we're looking at the structural bones. The polished marble facades, the glazed brick murals, the painted plaster, all that is gone. The monument has been stripped to its muscular frame. This changes how we interpret their skill. The brute strength to lift the blocks was only one phase. The delicate, patient skill to finish them, to make them weatherproof and radiant, was the final, defining act. It turned a feat of logistics into a lasting work of art and environmental engineering. The platform's true face was this final skin, a testament to a civilization's ability to master not just mass but the minute, the chemical, the beautifully detailed. So the silent stone we see today holds the ghost of a brighter, smoother, more colorful reality. A finished thought now whispered only by the faintest traces in the weathering patterns. The log under the stone is an icon. But it's a lie of simplicity. The real principle is the transport physics of rollers and sledges. A system much more intricate than just pushing a block over a few logs. It was a temporary road, a moving road, built and rebuilt with every step. The physics are demanding. A solid wood roller under that weight doesn't just roll, it compresses. It flattens where it touches the ground. That deformation creates resistance, and it damages the roller, splinters it over time. So the choice of wood mattered. Hardwoods, oak or elm, their dense grain could take the pressure longer. But even the best wood would fail, which is why you never had just 2 or 3 logs. You had a supply train, a crew whose only job was managing the roller path. Here, how it worked? The stone rests on a heavy wooden sledge, a platform with curved runners. Ahead of it, a team lays down parallel logs like railway ties. The sledge is pulled forward onto these rollers. As it moves, the rollers behind are left free, but the sledge hasn't reached the next set yet. This is the critical moment. The management team springs into action. They pick up the free logs from the back, sprint them to the front, place them ahead of the sledge. The road is moving from back to front. In a continuous loop, it's a logistical dance, perfect timing. If the front runs out of rollers before the back ones are recovered, the sledge stops. Its runners dig into the earth. This operation required coordination like a relay race, shouted commands, teams in shifts, a rhythm as precise as the puller's chant. Then there's the lubricant. Dry wood on dry wood still creates friction, so they introduced a middle layer, water or animal fat, vegetable oil, poured onto the rollers and the sledge runners. This thin film lowered the friction, turned a grinding drag into a slick, almost fluid motion. Some evidence suggests a slurry of wet clay, which would harden to a smooth surface as it dried, creating a literal slipway. This system was a brilliant improvisation, but every component was engineered. The sledges, runners were often sheathed in metal or hardened wood to prevent splitting. The rollers were cut to a uniform diameter for a smooth ride. The entire operation was a mobile factory of motion. It converted the linear pull of hundreds into the rolling translation of a mountain. So that classic image of stones on logs. See past the icon, see the frantic ballet behind it. A road that only existed for the minutes it took the stone to pass, then vanished. Its parts already running ahead to build the road again. From the air, the temple looks isolated, just a solitary masterpiece. But that's a trick of time. If you peel back the jungle with modern eyes with LiDAR scans, the truth comes out. The platform was never alone. It was the heart of a vast, invisible body. The 22nd principle is topographical integration. The platform as an artificial mountain woven into the living landscape. This wasn't just about finding a nice hill. It was about creating a new node in a sacred geography, a deliberate act of geomancy, engineering to harmonize the human and the natural into a single, resonant system. Take Angkor Wat. From the ground, you see the central spire, the galleries, the wide moat. But from above, with the forest stripped away by laser scanning, a grander design comes into focus. The whole complex is a microcosm of the Hindu universe. The central tower is Mount, the axis of the world. The walls are the mountain ranges. The moat is the cosmic ocean. But the integration goes beyond symbolism. The site's major axis is aligned precisely to the west, a direction for Vishnu, who the temple is for. And more than that, the entire hydraulic city of Angkor, the canals, the reservoirs, the temple mounds, was engineered to capture the monsoon's pulse, turning the landscape itself into a machine that reflected the celestial order. The platform was the control point in that engineered ecology. This logic of mirroring the terrain appears everywhere. In the Andes, buildings and terraces don't conquer the ridge, they echo it. The silhouette of the sacred stone in the Temple of the Sun mirrors the peak of it behind it. The city was placed to create a dialogue with the apis, the mountain spirits. The engineering followed the natural contours, making the built environment feel like a natural outgrowth of the stone. It was architecture as reverence. Ancient China, the practice of is maybe the most form of this. Selecting a site for a tomb, a palace, a city meant reading the dragon lines of the land, the flow of energy through mountains and waterways. A platform would be placed at the commanding position, often on a southern slope sheltered by hills with a view of water. This wasn't just superstition. It was a sophisticated system of environmental psychology and practical planning. The sheltered location gave protection from northern winds. The southern exposure offered sunlight. The proximity to water meant a vital resource. The engineering served to perfect these natural advantages. That required a staggering scale of surveying. To align a platform with a distant mountain peak, or to shape a city to mirror a constellation, meant thinking in miles, not feet. It meant generations of astronomers and surveyors reading the stars and the horizon, translating those alignments into permanent markers on the ground. The platform became a pivot point between Earth and sky, its foundations grounded in a cosmic blueprint. So the greatest platforms weren't constructions upon the land, they were conversations with it. The builders saw the landscape not as raw material to be dominated, but as a sacred text to be understood and answered. Their engineering was an act of alignment, physical, spiritual, cosmological. The stone they laid was the final word in that ancient dialogue. A master builder dies, but the platform has to keep rising. That's the 23rd principle, the enigma of preserving knowledge. How do you transfer a blueprint that takes a century to finish? How do you teach the exact angle of a ramp, or the secret mix for a plaster, or the rhythm of a pool to a child who won't see the final stone set? The answer is a different kind of infrastructure, not built from stone but from memory, from ritual, from social bonds. The projects themselves were the curriculum. A young person didn't learn from a textbook, they learned by joining the work. It was deep, immersive apprenticeship. A boy might start by fetching water for the mortar mixers. He'd watch. He'd listen to the chants that timed the lever crews. Over years, he'd move to shaping a stone under a master mason's eye, learning to read the grain of the granite, to feel the correct strike of the hammer. The knowledge passed hand to hand, tool to tool in the dust and noise of the site. The project was a living library. Every task, from quarrying to finishing, was a chapter taught through doing. But some knowledge was too vast for memory alone, too precise. They used physical aids, schematic tools that acted as portable memory. The Inca used a system of knotted cords, often thought of for accounting, but some scholars believe certain could encode narrative and technical information, a way to record a construction sequence or the measurements for a terrace system. It was a three-dimensional blueprint, decipherable by trained keepers. In other cultures, ground drawings or sand diagrams could map out astronomical alignments, or the footprint of a temple before the first stone was laid. These weren't written words, they were a formalized, repeatable code. And this technical knowledge was woven into the sacred. The rituals, the songs, the stories told at festivals, they weren't separate from the engineering, they were its vessel. A chant used to coordinate hauling teams might also tell the myth of the god for whom the temple was being built. The calendar that dictated when to move stones after the harvest was also a religious calendar. By embedding the how within the why, the culture made the knowledge sacred, essential to preserve. To forget the technique was to dishonor the gods, to break a covenant with the ancestors. That gave the transmission a spiritual urgency. This system created a chain of human continuity. A master mason wasn't just teaching a trade, he was initiating a successor into a lineage. The apprentice wasn't just building a wall, he was fulfilling a promise made by his grandfather. The project became the thread that stitched generations together, giving each person a role in a story much larger than themselves. So the silent stones speak of a social contract, a shared commitment to a future they would never see, held together by the careful, patient passing of a torch from one hand to the next across the dark gap of a lifetime. Concrete can fail in a single lifetime, it just crumbles into dust. But a stone platform left alone in the jungle might wait 1,000 years. That's the 24th principle, the strange logic of abandonment, where nature isn't just the enemy of a monument. Sometimes it's the savior. It's an ironic twist. The very events that ended a civilization, a shift in climate, a change in trade, conflict, those same events often saved its greatest works from being lost. Modern materials have a hidden weakness. Reinforced concrete has the steel inside can rust. It expands and it cracks the concrete from within. It needs constant maintenance. Without that, decay is swift, total. But the ancient platforms were built from geology itself. Their stone was already millions of years old. When a society moved on and the jungle or the desert returned, these structures didn't so much decay. They were reclaimed. It was a kind of protective burial. At Angkor, the sprawling temple complex wasn't destroyed. It was enveloped. The jungle sent roots through the stonework, but those same roots also bound the stones together, holding them in place. The thick canopy sheltered the carvings from the monsoon rains. The slow accumulation of soil and leaves created a stabilizing blanket over the foundations. The site became part of the forest, hidden and preserved. In the deserts, the story is sand. A city abandoned to the dunes isn't necessarily shattered. The sand blows in, it fills courtyards, it buries walls up to their roofs. It's a gentle shroud. It protects thee and stone from wind erosion. It seals them away from scavenging hands, from later generations looking for ready-cut building materials. That burial by sediment was a historical safe deposit box. The platform at one of the oldest known monumental structures wasn't toppled. Its builders deliberately backfilled it. Stone and soil around 12,000 years ago. Whether it was a ritual closing or something else, that act of burial is why its pillars were found in such condition. The earth preserved the carvings, locked them in a time capsule. The cataclysmic end of a society looks like fire and violence. But for the stones left behind, that collapse could mean safety. If no one remains to quarry the beautiful casing stones for a new palace, those stones stay put. If the knowledge of the site fades, it escapes the systematic recycling. The Roman Empire repurposed marble from older temples. Later builders used the pyramids as quarries. But a platform swallowed by the Amazon or sunk into the silt of a river delta became invisible. It waited. This cycle of abandonment and rediscovery shows a profound endurance in their original logic. They built for eternity not by resisting nature indefinitely, but by using materials that could become part of nature's own slow processes. The stone could withstand the weight of centuries of soil. The interlocking joints could hold firm even as trees grew around them. Their engineering anticipated stillness, not just use. So when we uncover these places now, brushing away vines or digging through sand, we aren't finding ruins in the sense of something broken. We are finding something that was successfully put into storage by time itself. The silence of abandonment was not the end of their function. It was the final, unintended phase of their preservation. The tools we used to see the past have changed. We have new lenses now. Ground-penetrating radar sends pulses down into the earth and listens for the echoes of walls that are buried. There's three-dimensional laser scanning, mapping a stone surface with millimeter precision, and it shows you the subtle wear patterns from ropes that turned to dust long ago. And drone photogrammetry, stitching thousands of aerial photos into a perfect digital model so you can see alignments across miles that a person standing on the ground could never see. That's the 25th principle, seeing with new eyes. These modern tools aren't just finding new sites. They're rereading the old ones, word by word, at a scale and depth the builders themselves might have recognized. It was their own kind of meticulous observation. We're starting to see the blueprint not as a static plan, but as a dynamic process. It's frozen in the geometry they left behind. Take the plain around Stonehenge. For centuries, it was just the circle and the landscape right around it. Then ground-penetrating radar surveys happened. They revealed a hidden cosmos under the grass. A vast network of ritual pits, processional avenues, smaller timber circles, all arranged in a complex pattern centered on those stones. This wasn't a lone monument. It was the heart of a sprawling ceremonial landscape, its logic written into the soil, and it's only now becoming legible. The platform of Stonehenge itself makes new sense when you see it as the focal point of this much larger design. Its placement was the final anchor, the permanent one, in a temporary world made of wood and earth. Or the laser scans of stonework. To your eye, the joints look tight, perfect, but the scan tells the true story. It shows the microscopic high points, the areas of greatest wear from centuries of subtle seismic shifts. And more than that, it can map the entire site's orientation with celestial bodies with an accuracy that was impossible before. We can trace the line from a specific window to a distant mountain peak on a solstice sunrise with digital certainty. It confirms the intentionality behind what people used to think was just symbolic or speculative. This technological reanalysis is the key to a quiet revolution. It's turning mystery into method. We're not just guessing how a multi-ton block was moved anymore. We can find the compacted soil of a temporary ramp, invisible on the surface. We can detect the subtle pathway worn into bedrock from thousands of trips with a laden sledge. We can see the quarry marks, the tool signatures, identifying the sequence of work from extraction to final placement. Each data point is a recovered piece of their thought process. It lets us reverse engineer their decisions, not as magic or myth, but as a comprehensible sequence of rational solutions. They were solving immense physical problems. The ancient mind is being decoded. not through a rediscovered manuscript but through the silent testimony of angles and alignments, of subsurface structures and stress patterns. The platform under this new gaze stops being a question mark and starts becoming an answer. It speaks in the clear language of engineering, of astronomy, of logistics. Our new tools are finally letting us listen. The last idea isn't about history, it's about a blueprint we might still be missing. The engineering logic behind these old platforms, the forgotten part, speaks directly to us now. It asks a question. What can a civil engineer today learn from a master builder working 3,000 years ago? The answer isn't about copying their techniques. It's about recovering a mindset, a way of thinking that puts sustainability and resilience first and harmony long before those were technical terms. Their logic came from absolute necessity, from patient observation. And it offers a sharp critique of our own approach, which is so energy-intensive, so high-tech. They remind us, true sophistication isn't always the material or the most powerful machine. It's the most elegant solution, specific to its place, to the universal problems of load and mass and stability. Take sustainability. They were masters of local sourcing. A platform in the Andes used andesite from the mountain right there. A temple in Cambodia used sandstone from a quarry you could reach by river. They minimized transport energy because they had to. Every ounce of fuel was human food. Their supply chain was the landscape itself. That stands in stark contrast to what we do now. Globalized construction. Materials shipped across oceans, burning vast amounts of fossil fuel. Their principle teaches a radical efficiency. Build with what the land provides. Shape the design to the material, not the material to some distant, abstract design. That local logic made structures that were chemically compatible, physically compatible with their environment. They didn't fight the local climate, they were made from it. Then resilience. We saw how their interlocking stonework, their trapezoidal forms, danced with earthquakes. Modern engineering often fights seismic force with brute strength. Reinforced concrete, steel frames, dampers. Their approach was different. They designed for flexibility, for energy dissipation. They built structures that could absorb a shock, settle, and remain standing. We are only now, with advanced materials science, coming back to these principles of flexible, non-rigid design. Their ancient platforms are case studies in longevity. Our own concrete structures, with their limited, their constant maintenance demands, they struggle to match that. They built for the multi-generational timescale, for the certainty of geological change. We often build for the economic cycle. And most importantly, their practice was holistic. They didn't see a building site as a blank slate. They saw it as a node in a living system, a platform at integrated water management, solar alignment, agricultural terraces. Angkor Wat was the heart of a vast hydrological machine. Their engineering was inseparable from astronomy, from agriculture, from ecology. It was all one system. Modern specialization splits it apart. The architect, the civil engineer, the environmental planner. Their work splinters the project. The ancient model suggests a lost unity, a way of planning where the structure's purpose is woven into the environmental fabric, the social fabric, from the very first survey. So this legacy whispers a quiet alternative. In an age of climate urgency, of resource constraints, their logic is strikingly relevant. It champions low-energy solutions. It prioritizes durability over disposability. It seeks a dialogue with nature, not a declaration of war. Their sophistication came not from overcoming constraints with external power, but from listening to those constraints and finding the graceful solution hidden within them. The monumental stone platform, then, is more than a historical artifact. It's a testament to a different kind of intelligence, one that we, with all our technology, are still struggling to fully comprehend, and maybe urgently need to relearn. Granite and limestone can teach us. They really can. The platforms left by ancient cultures, these monumental structures, they aren't fragments of some lost, magical past. They're chapters from a universal textbook. A manual of applied physics, sociology, environmental science, carved right into the living earth. We've walked through 26 principles, from the geotechnical wisdom of the foundation to the psychological power of awe, from the silent efficiency of modular design to the resilient dance with seismic force, and each one reveals a logic, a rational, repeatable, deeply human response to an immense physical challenge. This wasn't a secret science. not handed down by gods or visitors from the stars. It was a science of observation, trial, error, and brilliant adaptation. And it emerged independently across continents because the problems were the same everywhere. Gravity, friction, time. The solutions converged because human ingenuity, when faced with a mountain, follows a certain path, a beautiful and inevitable one. By rediscovering this forgotten engineering logic, we don't diminish the wonder of these places, we elevate it. We replace a shallow mystery with a profound respect. To say a society moved a 200-ton stone because they had alien help, that's an insult. It strips them of their intellect, their patience, their collective will. The truth is far more impressive. They did it with levers and ropes, with ramps of earth and a rhythm of chance, with a generational patience we can scarcely fathom today. They did it by mastering their world through careful, relentless study. They were civil engineers, project managers, master masons and astronomers. Their genius was in seeing the potential in a log, a slope, a round stone, and weaving these simple elements into a system that could reshape geography. This legacy isn't locked in the past. It speaks directly to our present and to our future. In an age of complex, energy-intensive technology and disposable construction, their logic offers a quiet, powerful alternative. It champions local materials, elegant simplicity, resilience built into the very fabric of a design. They engineered for harmony with their environment, not dominance over it. Their platforms were conceived as part of an ecosystem, managing water, aligning with the heavens, standing firm against the trembling earth. That holistic vision, where engineering was inseparable from ecology, culture, and cosmology, that's perhaps their most vital lesson for us now. So the next time you see a photograph, a cyclopean wall, a towering pyramid, look past the sheer scale, see the intelligence, see the careful preparation of the ground, the shaped stone designed for its journey, the invisible geometry of the joint. See the thousands of hands moving as one, fueled by the surplus of the harvest, guided by knowledge passed from father to son. See a civilization's deepest beliefs made solid, meant to converse with the stars and outlast the ages. These stones are a testament, not to what we have lost, but to what we have always been capable of. They challenge us to look at our own world, our own pressing challenges, and ask, what does truly sustainable, resilient, and awe-inspiring engineering look like? Perhaps the blueprint has been here all along, waiting in plain sight, written in the patient language of stone.